Hello to my online Foundations of Math 2 students. I'm going to try to get as much covered in about 15 minutes as I can because YouTube limits me to 15 minutes on these videos. So just because I'm not covering something that's on the list doesn't mean it's not important, but I'm going to hit the highlights. Be sure you know the 7 types of graphical representation, know how to find mean, median, and mode, know how to find quartiles if you already know the median. Now, I'm going to talk about the normal distribution bell-shaped curve because a lot of my students have been missing this in the past. An entire population at the mean has the symbol mu. A sample population has the symbol x bar to represent the mean. And so from there, we go up 1 standard deviation and 2 standard deviations. Sorry, that should be sigma. And then 3 standard deviations. For our sample population, it would be x bar plus s, x bar plus 2s, and x bar plus 3s. If we're going down from the mean, it'll be mu minus sigma, mu minus 2 sigma, and mu minus 3 sigma. So it'd be x bar minus s, x bar minus 2s, and x bar minus 3s. Now, if we're turning our data into z-scores, the z-score of 0 falls at the mean, which means if you're at the mean, you are better than 50% of the students, which places you at the 50th percentile. That means that if you had a score that falls right here on the mean, you are better than 50% of all 50% of all students. And if you're 1 standard deviation above the mean, you have a z-score of 1. If you're 2 standard deviations above the mean, you have a z-score of 2, or 3 above. This would be a -1, a -2, and a -3. Now, if you have a z-score of 1, you're going to be at the 84th percentile, because not only it means you scored right here with these people, and that means you scored not only better than 50% of all the people, but you also scored this much more better. Now, how do we know how big this distance is, or how many percentiles are in there? Well, we know that between plus and minus 1 standard deviation from the mean is 68% of our entire population. That means that 34% will fall from here to here, and 34% will fall between here and here, from our mean to 1 upper standard deviation. So if you add 50 plus 34%, that means you're at the 84th percentile when your score falls here. So I'm just trying to cover the basic concepts of the normalized standard bell curve. Now, the next thing you're going to need to be sure that you know is how to find the standard deviation of a set of numbers. So this is an example standard deviation. You need to know this formula. You are allowed to put this formula on the back of your test, but I do not want you to put numbers. But this is an example of how to find the standard deviation from a set of numbers. You add up the squares of the numbers here. You divide by however many numbers you have. Then you subtract the square of the mean. And here I have worked out each of these by hand. The first thing I did was I found the mean, and then I used that right there in the formula. And so once you work this out by hand, you just do each of these. You figure out what they are, you subtract, get that number. The square root of 12.56 is 3.54. So that's the standard deviation for that set of numbers. Let's talk about the permutation and combination formulas. This is the actual formula for permutations. Now, if I'm going to apply this, I would have 8 factorial over 8 minus 3 factorial, which ends up being 8 times 7 times 6 times 5 factorial, and I'm stopping there because I have 5 factorial in the denominator. which means I can divide out the 5 factorials, leaving 1 over 1, and my answer is just 8 times 7 times 6, which is 336. Okay, which I knew was the answer. Now, here's a shortcut. Whenever you're taking the permutation of 8 things, taking 3 at a time, here's what I do. I use this number art, and I make that many places. I make 3 places. Then I fill in the places starting with 8 in, and I go down by 1 each time. 8, 7, 6. That ends up being the same thing as what you end up with over here, and it gives you 336. So that's the shortcut for the permutation formula. Now I'm going to talk about the combination formula with regard to its being equal to the permutation formula. This part is the permutation formula. So basically, if you just say that this part is the permutation formula and you divide it by r factorial, this is the shortcut that I use to find the combination. So if I'm going to find the combination of 10 things taken 4 at a time, I put the permutation of 10 things taken 4 at a time, and I divide it by 4 factorial. That's going to equal, I'm going to make 4 places, and then I'm going to divide that by 4 times 3 times 2 times 1. I'm going to fill in these upper 4 places starting with 10, 10, 9, 8, 7, and now I'm going to divide things out. 2 times 4 is an 8, leaving me 1 and 1 down there. 3 goes into 9 3 times. So 10 times 3 is 30, and 3 times 7 is 30 times 7 is 210. So there are 210 combinations of 10 things taken 4 at a time. All right, let's talk about odds and probability and complementary events. If I have a bag of marbles where I have 3 red, 2 blue, and 5 green marbles in there, what are the odds in favor of drawing a blue marble? Okay, so we're going to ask ourselves that question. What are the odds? Well, we have to think of complementary events when we do odds. Okay, what is the complement of drawing a blue marble? Well, it's not drawing a blue marble out of the bag. So what you do to do the odds is you state how many ways you can actually achieve your given event, which is drawing a blue marble. That's 2 marbles. So we have 2 ways to draw 2 marbles. But then we have 5 green and 3 red. So there are actually 8 marbles that are not blue. So it's how many marbles are blue versus or against or 2 number of marbles that are not blue. That's how you use complementary events to do odds. It's 2 to 8, or 2 versus 8. Now, you can actually reduce this to 1.4 because they're both numbers are divisible by 2. So that's how you can reduce that answer. Okay, so then how does that relate to probability? What is the probability of drawing a blue marble out of the bag? Well, a probability is a fraction. So we put the number of blue marbles on top, which is 2. We have 2 blues. But then, as our denominator, we have the total number of marbles in the bag. And that would be 10. So it's a different measurement or a different number mathematically when you do probability. Now we can reduce that fraction to 1/5. So the probability of drawing a blue marble is 1/5, while the odds in favor of drawing a blue marble are 1 to 4. I hope that helps clarify things. Now let's talk about some terms. We're going to talk about complementary angles adding up to 90 degrees, supplementary angles adding up to 180 degrees. This is a picture of adjacent complementary angles. This is a picture of adjacent supplementary angles. So if I drew a picture like this where I have line M and line L, they intersect at a point. It creates 2 vertical angles, angle 1 and angle 3, angle 2 and angle 4. So angle 1 and angle 3 are vertical angles, and they're also congruent. Let's take a look at another example. Oh, that's a joke. We'll keep going. I'll let you look at that. Okay, what if I had two lines, L and M, and we knew that L was parallel to M. Angle 1 and angle 4 that I've marked here are vertical angles, but look at angle 1 and angle 5. Those are corresponding angles. Angle 5 and angle 4 are alternate interior angles, and they are congruent. Angle 1 and angle 5 are corresponding angles, and they are also congruent. So you need to know these terms to take the test. Another way that I test whether you know some terms is I give you a drawing similar to this. We can know that angle 1 and angle 4 are vertical. They're also congruent. What if I know that angle 6 is 95 degrees? Well, that tells me if angle 6 is 95, what is angle 7's degree measure? It's also 95 degrees, isn't it? Okay. What about angle 8? Can I know what angle 8 is if I know that angle 6 is 95? Well, yes, you subtract 95 from 180, and I believe it is 85 degrees. Okay, so that means that angle 5 is 85 degrees. And because of corresponding angles, 1 and angle 5 are corresponding, so I know that angle 1 is 85 degrees. So is angle 4. Angle 2 is going to be 95 degrees. And angle 3 is also going to be 95 degrees. Now, coming down to angles 9, 10, 11, and 12, if angle 12 is 70, I know 9 is 70, I know 13 is 70, and I know 16 is also 70. Likewise, when I subtract from 180, I know that angle 10 is going to be 110 degrees, so is angle 11 because it's vertical. It's also supplementary to angle 12. We're going to have 110 degrees here at 14 because it is corresponding to 10, and 110 degrees here because it's vertical to 14. Now that I know angles 3 is 95 and angle 13 is 70, I can find angle 7, the measure of angle 17, because 95 plus 70 is 165 degrees. And when you take 180 degrees, which is the sum of the angles of any triangle, and you subtract 165 degrees, you get that angle 17 is 15 degrees. Okay, next we're going to talk about isosceles triangles. This is an isosceles triangle based on its sides. Okay, it is acute based on its angles because they are all angles are less than 90 degrees here. They're little and they're cute. They're less than 90 degrees. Now, this triangle based on its sides is a scalene, okay, because all three sides are different. Based on its angles, this is an obtuse triangle because this angle is greater than 90 degrees. All right, you also are going to need to know Euler's formula, V plus F equals E plus 2. For instance, if I give you that the number of vertices is 10 and the number of edges is 15, how many faces are we going to have? Well, we need to do a math problem. 10 plus F equals 17. So F will equal 17 minus 10, so the number of faces is 7. Let's go to the next problem quickly because we're running out of time. That's a joke. Oh. Okay, area conversions. This is an example that I did. All I did, this part was blank, okay, earlier. And the way I figured this out is I started with this fraction, 282 meters squared over 1. And then I had to use the fact that 100 centimeters is equal to 1 meter. And then I had to square both of these to find out that there are 10,000 centimeters squared in 1 meter squared. And I used that fact over here to figure out my final answer. Because in order to convert from meter squared to centimeter squared, we have to have square measurements. So 282 times 10,000 is 2,820,000 centimeters squared. So study that. And last but not least, oh man, I have no time left. We were going to have to do a mirror here to create similar triangles. If I'm 5.5 feet tall, I need to know this measurement, let's say, is 5. I need to know this measurement is 20, and there's right angles here. So you create congruent angles when you do a mirror that looks at the top of the tree. Man, I've gone about 15 minutes. I hated to do that. Okay, so this is going to be by angle, angle, matching angle, angle. These triangles are similar by the angle, angle similarity property. And you're now going to be able to get the scale factor. 20 over 5 is going to be 4. So your scale factor is 4. And the way you're going to set up the ratio to find out how tall the tree is from here to here is 20, the larger triangle side, over 5 is going to equal x over 5.5. And you'll do cross multiplication to solve this. 5 times x equals 20 times 5.5, which I believe is 110. And when you divide both sides by 5, you get x equals 22. So the poplar tree is 22 feet tall. And I'm going to stop it. I hope this helps.